will be on GeoNode, an introduction to GeoNode, and also a demo. And our presenters are Cristiano Giovando from the World Bank and Paolo Corti from here at Harvard University.
Well, thank you, Faye, and thank you everyone for joining us today. Thank you to the organizing committee of this symposium for inviting us. My name is Cristiano Giovando. I'm with the Global Facility for Disaster Reduction and Recovery at the World Bank. And I'm joined by my colleague, Paolo. Paolo Corti is here in Harvard. We're actually both Italian. We both worked in Italy before. We were colleagues at the European Commission. Then we independently moved to the US, and then randomly we were asked to come here today and make a presentation about GeoNode. So it's fun to see friends again. And any of you know about GeoNode or what GeoNode is? Or there you go. So before getting into GeoNode, let me just give you a quick background of what we do. What we do at the World Bank, GFDRR. These are projects from the Innovation Lab, a specific group within the World Bank. And we support different projects around the world, and these are just in the recent 5 years. Project to support communities and countries to become more resilient to disasters and to shocks. So most of these projects have a spatial aspect, spatial component, and we use this approach of developing risk information to inform decisions for the government and to prepare the community. So we go through these different phases of when we develop a project, where we first make an investment, and together with the community, we rethink ideas on how to make the community more resilient, and then we implement them. So we prepare the community, and then through financial investments, we make those communities. We protect those communities through financial protection initiatives. And then after something happens, we help them to respond and recover and do damage assessment to assess the damage, and then help them to assess the actual needs. So we create these projects also to create a portfolio and reference examples, reference guides that then can be used to for other communities, for other countries, to understand how we can use open data to improve resilience to disasters. So three main aspects or three main components of this approach are defined in the Open Data for Resilience Initiative, or OpenDRI. And that's the group that I'm working with at the World Bank. The three components are sharing data, collecting data, and using data. And today, with this presentation, and specifically for the presentation on GeoNode, we're going to focus only on sharing data. There are aspects of collecting data that we support through teaching about OpenStreetMap, for example. I also work with another group called Humanitarian OpenStreetMap, where we work with communities to help them to collect data, to build this data set that then go into a platform such as GeoNode, where it can be shared with others. And then using, there's other project at the World Bank where we support the development of tools for analyzing the data, do flood modeling, and remote sensing analysis applications. The Open Data for Resilience Initiative is based on 9 principles that we support when we start a project, and that the data should be open by default. It should be co-created with the community and with the government. Should be made accessible. The project should be sustainable, so there should be a sustained engagement from the government and from the other partners in the project. We support the development of open source tool. We work with different commercial partners or other companies to develop open source tools that also integrate it with existing commercial platforms. We also help to create partnerships, and to make it really sustainable, we want the project to become owned by the community, and so we find and we implement strategy to own to have the community own the project and institutionalize it. So going back to the one aspect that we're gonna be talking to today, GeoNode. What is GeoNode? GeoNode is an open source geospatial content management system. Some of you may be familiar with Joomla or WordPress or other content management system for the web. GeoNode is basically the same thing, but for geospatial data. So if you have your shapefiles, your geotiffs, all your spatial data formats, GeoNode makes it easy to share it, to upload it onto a web platform and share it. If you go to geonode.com, you will see exactly this screen, and you will find a documentation. You will find an installer if you want to install it. You can even try the demo, and we're going to do this today. Paolo is going to do specifically a demo on the live demo. GeoNode, as I mentioned, it's an open source tool. It's been like open source since the beginning. It's been over 5 years now. All the code is available online on GitHub. It's been over almost 10,000 commits, 10,000 edits to the code, and over 125 contributors. Anyone can go onto the nice thing about open source software is that you can quickly go to the source code. You can go to this tab where it says issues, and if something doesn't work, you report it, and probably in minutes or hours, someone is going to say, okay, let me fix that. So that's the type of reaction that you get, the dynamicity that you get from open source projects. As I mentioned, GeoNode was started about 6 years ago now as a project sponsored by the World Bank, the Central America Probabilistic Risk Assessment Platform, or CAPRA. And then over the 5 years, it went to the 2.4 version, which is the current one, was released last November. And then right now, there's a roadmap for GeoNode 2.5, and Paolo is going to show you some of the features that will be released soon in the next couple of months. GeoNode is similar to some of the commercial frameworks. There was a presentation, I guess, right before this one about CartoDB. That's a commercial implementation of the similar concept. Mapbox is also something similar like this. our Geoserver, our GeoOnline, all similar frameworks. Then there's some other open source tools or frameworks like GeoNetwork, GeoMahas, GeoMoose, MapBender. These are all similar. They might not have all the features that GeoNode has, but they're all available for free and open source. Who's using it? We use it at the World Bank, not just in our group, but now many other groups within the World Bank are using it. United Nations, WFP, they're using it heavily. They even made a full customized version. The European Commission, GRC, the US Department of State is using it. And actually, for the secondary city website, it's right there. We can see then. And then several universities, including CGA here at Harvard. Paolo is actually working on one of those world map, and actually there's a presentation later, I think, the next group, specifically about that. So it's another more detailed look at world map. And then, as I said, many local government and offices and agencies are now seeing the opportunity of using GeoNode to share data easily. Just install it, set some parameters on how you want to share the data, and easily you can share it with provinces, districts, cities. It's that easy. Who's GeoNode for? Users. Any one of you can go to the demo, demo.geonode.org, and just browse and search geospatial data. There's not much on that specific instance because it's a demo gets resetted from time to time. But you can go to a GeoNode and browse and search for data and use the data. You can upload the data if you have permission or if you register to a public GeoNode, and you can create interactive maps, basic interactive maps that you can style and set with different different features. And there's also the social aspect, and I'll show that more in details. For developers and for administrators, you can use GeoNode and easily extend it. It's all, as I said, open source software based on Python and JavaScript. For those of you more technical, know that it's pretty easy to make a full customization of using those programming languages. For administrators, as I said, you can set up a hub where you can share your data and quickly have it compliant to all the OGC services. It's a full SDI implementation, for spatial data infrastructure implementation, where your data, it's uploaded and it's made available through OGC services, and as we see also the catalog services. So as I mentioned, uploading layers is as easy as going to the upload page and just drag and drop a zip shapefile. So you can upload it and then set permission on who can view it, who can download it, and then for creating and styling maps, you have a tool called GeoExplorer, where you can set the style and rendering of your layers. And once the map is created, you can just send a link to anyone, and it's accessible, and you can display your data however you want to style it for that specific purpose. One other important aspect of the cycle that I described before is the creation of data. You can import data, but you can also create it. So if you work with a community or with a group and you're doing digitizing buildings, for example, or features, you can do that collaboratively in GeoNode, where you can add the polygons, lines, points, and add attributes and information about the data. And it's all saved automatically online, and it becomes accessible as services, as OGC services. An important thing that was mentioned before about metadata, GeoNode really stresses the importance of metadata. Without metadata, you cannot find the data. You need metadata to make your data rich and easily discoverable. So GeoNode implements several schemas for metadata, ISO, FGDC, and Inspire. And it's set up in a way that it's easy, or at least not as boring, to fill in the information for the metadata elements. Right now, we're actually working on even a nicer interface to encourage people to contribute more metadata, more like a gamified version where users are rewarded for adding metadata, right? As I said before, different levels of access control. There's some data might be sensitive. There's some data you only want to share with some groups. So GeoNode is set up from the source, from the actual OGC services, to handle all of that and set specific permissions. Of course, we always want to encourage people to share data openly, but again, we have these options in GeoNode to restrict the access. GeoNode is one of the few platforms that has a full catalog service for the web CSW endpoint. So you can actually take the URL from the GeoNode and go into a desktop.js, in this case QGIS, and browse or search that catalog. So you don't even need to have or to go online on the platform. You just go from QGIS and search any keyword or any type of metadata. You find all the layers, and you can import it as WFS or WMS directly into your JS. And that uses PyCSW. as I said, there's automatic by default options to exploit the information in all the layers. So all the OGC standards, even WPS, web processing services, can be the data could be used through GeoNode. All the more familiar formats, and even like just simple maps, zip shapefiles, GeoJSON, KML. And the other aspect of GeoNode has been developed, and it's already available. Some of the features are already there. It's all the social aspects of sharing data in a community, in an online community, in a local community. And so we, or the GeoNode developers, developed some features like rating of layers. Some of the most popular layers can be rated by the users, can be shared directly with a link directly to Facebook or Twitter, and then there could be comments for each of these layers and automatic notifications for other users to be notified. For example, if I'm uploading some layer, I'm the owner of that layer, someone says, hey, there's a problem, this data is not updated, I receive a notification by email saying, receiving that message, and then I can interact with the other user. So that's an important feature, part of the GeoNode platform. And as I said, it's easily customizable. These are some of the examples of GeoNode that we use or that we develop. We support the development through the World Bank. The Malawi Spatial Data Portal, that's another platform in Russia. Here's a platform that has been developed in Haiti after the earthquake and cholera outbreaks to increase the sharing of data. And that's another platform in Sri Lanka that collects data for flood risk and other risk information, and has been used recently during the flood in May 2016. I'll leave it to Paolo right now. He's going to tell you a little bit more details about the actual what's behind GeoNode, the technical aspects, and then we're going to do a quick demo, showing you exactly how it works.
Thanks, Cristiano. So, as discussed, the World Bank founded the project 6 years ago, and from then a big community of contributors developed within the context of the project. So now we are more than 100 contributors to the project. And if you go to the GitHub platform, that is the platform that is hosting the source code of GeoNode, you will see that the project is under big activity with a lot of open tickets, but also a lot of closed ones. And, there have been more than 1,000 pull requests. A pull request is basically a request to change the code from a different developer that is in the context of the community, and it can be accepted or not. So most of them were accepted. And there are many users also from mailing list. The mailing list is there is a lot of traffic on the mailing list. One interesting thing is that we are trying to organize at least once a year a GeoNode code sprint. So basically it's a global event where the developers are trying to meet to discuss new lines for the future development. And we actually do coding, and we try to release a new version of GeoNode. Last one was a combined sprint between Italy in Turin and US in New Orleans. But as you can see, there were more sprints in the past. They were mainly hosted from organizations using GeoNode. So now let's have a quick look to what we are going to implement in the next release of GeoNode. This can be mainly interesting to people that is already using it. I will be quick anyway. So one of the improvements we are considering is to improve the API, that is an interface for developers to provide additional features on top of GeoNode. And another interesting thing that has been discussed quite since a long time is provide additional web map engine to GeoNode. GeoNode, for map rendering, it uses an open source platform that is Geoserver. And this was from the beginning, since 6-7 years now. But a lot of organizations are requiring to use a different platform because maybe they had a different choice within their organization. So there are a lot of organizations that, for example, are using map server and they are asking for support for map server. And we are discussing about it. So far, there is already very close the support for QGIS server that will be available in the next release. So one interesting thing, and here I will open a parenthesis on the GeoNode instance we are using for deploying world map. It's world map because since the beginning of the world map project, this was highly customized in respect to the GeoNode mainstream. And therefore, world map provides a lot of useful features that are not currently in GeoNode mainstream, but we would like to port them to the mainstream version. So already for the next version, we are considering to port to mainstream GeoNode the classifier, the styler that let the user to classify by attribute in the map composer. The map nodes application, that is basically an application that let the users to add nodes on a layer or on a map. The map snapshot revision product that keep the history of maps and let the user to revert to an old version in case there is an error or in case there is a need to come back to that version. Then one interesting feature that unfortunately is not available still in GeoNode is the possibility to create a layer from scratch. So now in GeoNode it's possible just to upload existing dataset. In the next version it will be possible to create a vector layer from scratch. So it will be possible to decide what kind of geometry the layer will contain, if point, lines, or polygons, and which attributes, and so on. Another product we're planning to port to GeoNode mainstream is the gazetteer for layers. The gazetteer for layers let the user to upload one or more layers and to define for some of the field of those layers to be part of a gazetteer. Other things that are in world map and will be in world map soon, and that we are planning to port to GeoNode, not maybe for the 2.5 version, but maybe for the 2.6, we will see, are described in this slide. So a first product is the data table application. This application lets the user to make joins, table joins on existing layers. So this is very interesting. Another feature of this product is the possibility to upload lat-long text files that will be created in GeoNode as point layers. We have been working in the last few months on a platform which name is Hypermap, and that is basically a map service registry that enables search and discovery across federated GeoNode and other catalog system. Basically all systems that expose OGC endpoints or SA services. About these, and also about the other two things I'm mentioning in a while, make sure to follow the talk by Ben, my colleague, that will follow later in the afternoon. In the next few weeks, we have started the work for the feature search possibility. basically the user will be able not only to search for layers and in the context of the metadata of those layers, but also inside the features that are composing the vector layers. So, for example, it will be possible to find a layer that contains a keyword in one of its features. Another platform is currently under deployment, is related to big data and real-time geovisualization system. We are also planning at some point to port it to the GeoNode mainstream. Now, a few words on the stack that on top of which is built GeoNode. One thing that is very relevant is that all open source, it's a stack composed of only open source product. So everyone can take it, download it, and install it in its computer. So we are using, as a web platform, as a web development environment, we are using Django, that is a popular Python framework. It has been out for a while now, because I think it's almost 10 years old right now. And it's very powerful and scalable, so it's really a good choice. We are combining Django with Bootstrap and with jQuery. Regarding the mapping engine, as said, GeoNode currently use Geoserver, that is another open source web mapping engine. Thanks to Geoserver, GeoNode expose quite a big number of OGC protocols. The most notable ones are those that you see in this slide: WMS, WFS, WFS transactional for the editing, WHES, WMTS, and WPS. Geoserver also exposes a RESTful API that let the user to remotely configure the instance. All vector data are stored in a relational database. The default one is PostGIS, that is quite a popular one. It's object relational. And the spatial, and thanks to PostGIS, that is a spatial database extender, it supports spatial, it enriches the SQL syntax with the spatial function. So it will be possible to do spatial search using SQL, basically. This is why we are choosing it. Regarding metadata, once GeoNode came with GeoNetwork, it used to come with GeoNetwork until version 2.4. Now we switched to PyCSW, that is a lightweight Python implementation. Note that is the current reference implementation of the OGC CSW standard. In case one organization wants still to use GeoNetwork, it's possible because it's easily replaceable. Mapping client. So mapping client is what the user will say when composing maps. The default one that comes with GeoNode is GeoExplorer. It's quite old-fashioned now. It has been out for a while, since 10 years, since 8 or 9 years. And it's built on top of the XJS JavaScript framework and OpenLayers version 2. Thanks to this framework, thanks to GeoExplorer, the GeoNode user is able to make data editing, to edit styles, to query maps, and to compose a map and print them. Since a couple of years, there is also the possibility to use an alternative client to GeoExplorer, that is Maploom. Maploom is based on a more modern JavaScript framework, Angular, and is built also on top of Bootstrap and OpenLayers version 3. One of the notable things of the Maploom client is its tight integration with GeoGig. GeoGig enable in GeoNode the versioning for features. It's an optional component that can be installed, and it's useful in case when it's needed it's needed to track change to data to know the history of features while they are being edited. When it's necessary to revert to previous states of a feature. And it has been already used in many GeoNode instances, especially in instances that have been created in the context of natural disasters. One example is the GeoNode instance that was created a couple of years ago when there was the typhoon Yolanda in the Philippines Islands. There is also the possibility to use a search engine within GeoNode. I mean, GeoNode comes with already several search features, but if you need a more advanced search engine, it is possible to install one. And actually, there are two alternatives, both of which are based on the popular Lucene library. And those alternatives are Apache Solar, that is the one that we're using currently in WorldMap, and Elasticsearch. A final mention to all of the libraries that are being used for all within all the tools that are composing the GeoNode stack. The most notable libraries are GDAR or GR, Geos, Proj, and GeoTools. Okay, so now I think we have still a few time to have a demo.
If there are any questions now while we just switch to the demo, otherwise we can also take questions during the demo. Okay, if you go to geonode.org, this is the page I mentioned before, and there's a link to the demo right there. This is as I mentioned, an instance that has been created for anyone to use, even with admin access, just because you get the full feel of what GeoNode is and how it works. So it gets rebooted and reset from time to time. So just to go through some of the main features, when you enter a GeoNode instance, you have different sections up here where you can see the layers. As you can see on the side, there are different metadata information that is organized by different metadata groups. There's the Maps tab. Right now there's no maps. We're going to create one. There's actually a section where users can upload documents, known geospatial data. GeoNode has been developed to also support that. If you have PDFs, reports as being created, you can include those in the content management system. And as I mentioned, the social aspects. So there's a list of users, and then groups if there's any groups created for those users. With regards to the administrative side, there's a link up in the top right where you can search, where you can get access to changing information about your profile, configuration option for the administration side, and also for Geoserver itself. So let's get to layers here. And as I said, you can search them here, or you can upload a layer. So in this case, as I showed before, you can either drag and drop files in here, zip shape files, or you can select it. Here in this case, for example, community health centers here in Boston. And you just do upload. It gets transferred onto the this community instance, and then the layer is created. If you click on layer information, it takes you to a map where you can actually see those points. In this case, just a quick preview of that layer. You can edit the layer. In this case, you can edit the metadata. Here are all the fields that I mentioned before. But you can also change the style or replace the layer if you have a more updated version of that specific layer. With that layer and with other layers, you can, for example, create a map. You can choose between a base map, imagery, OpenStreetMap. You can configure it to have different background layers. You can configure the extent, and then you can add more layers. You can find them, or in this case, these are layers that already exist in this instance. In this case, we added metro lines for Boston. And then when you're done, or actually, let's zoom in, change the background. You can change the properties of this layer. You can, for example, set rules. If you have specific styles already predefined, you can use those. You can set limits by scale, limit with filters, and if you go to back to the layer list, you can actually change the style itself. Thank you. And change the color of the pointers. In this case, the stroke. And that gets automatically updated on the map. Once you're done with the customization, you can save it. Boston map. And that becomes a map that is available to anyone or those who have access to view it in the list of maps right here, with the same extent, with the same feature and styling that we defined before. Yeah?
So is that an attribute table you're bringing in, or an Excel sheet, and it makes the map?
The data that I uploaded,
Yeah.
it was a zip shapefile.
Oh, it was a file, okay.
Yeah.
Okay, so can you upload an Excel or an attribute table to do that?
Not yet.
Okay.
But the next
sorry.
version, as Paolo mentioned, will have the capability to have a CSV file with the coordinate sets and attributes. Yeah.
Yeah,
As I as I mentioned before, as I mentioned before, you can get to a layer that has been created. In this case, we're gonna do it with this one, where you can actually edit the features themselves. Can you do it from the map here? Okay. So you go to your map, you select the you select the layer that you want to edit, and then you click here, and you modify. And at that point, if you set the right, oh, great. In this case, for example, you can add a new point, and you can input all the attributes for that specific point. It warns you if you don't save it. I don't want to save it right now. And as I mentioned before, all the layers here have an option to download those layers directly, as for example, to view direct in Google Earth, to view it as a GeoJSON file, or to, in case of these points, for example, you can download it as an Excel or CSV file, or again, re-download it in a zip shapefile, or just get an image. And like in this case, as you can see, for those of you more familiar with OGC services, this is just a call to the WMS service, underline in this case. And yeah, question.
Well, as you mentioned at the beginning, these are all available as map services. So another system could bring this layer in that you just created and view it inside some other client. It could be QGIS or,
Yeah.
you know.
If
And
I can.
do you know whether editing is possible? Is it, I know there is transactional WFS, but I'm just wondering whether anybody's doing it with GeoNode and, say, QGIS. Because that would be really cool. Because then central database, 5 different groups anywhere in the world could be hitting it, collaboratively editing it.
Okay. Paolo from the.
I mean, this is something definitely possible, and I'm sure it was working at some point to edit within a client that is supporting the WFS standard, sorry, the WFS transactional standard, such as QGIS. I'm not sure if currently it's working. Yeah, sorry. Thank you. Sorry. So. Yes. So definitely, if the client you are using is supporting the WFS standard, and QGIS does, it is possible to edit the features from QGIS. Not sure if it's actually working, but at some point I'm pretty sure it was working. So we should check.
It's very feasible.
I think Cristiano now will.
I'm trying live, so we can see. But yeah, just to.
But it's also interesting to see how a layer can be added in a client such as QGIS, but also it would be possible from ArcGIS in the same fashion, using the catalog or using the WMS endpoint.
Yeah. So in this case, I added the that layer or the GeoNode instance or the Geoserver WFS service here in QGIS. I'm gonna try to add it here. Those are the points there on the map. So if I switch off the aerial, there they are, right? With regards to editing, if I can find it here on my, okay, let's just move one here. I deleted that feature now, so I'm trying to
Of course, it would depend on whether you had transactional WFS turned on the server, because you wouldn't always want that turned on.
yeah, that might be the reason. It's
You
giving
wouldn't
me
want it
here
on by
a
default.
message that I cannot commit the changes, so that might be the reason why.
Yeah, a related point. I mean, one of the great features here is the possibility of drawing in layers and having users edit and so on. That also brings the problem of inconsistency. So do you have like a troubleshooting feature? You know, you've got geos, so do you ask it, are these polygons okay? Or, you know, do they have intersections? Are anything like that in the works?
Yeah, I'm not aware personally, probably may add to that, but definitely should be relatively easy to implement through the topological rules like supported through Geos, right?
Assuming that the WFST standard works, I mean, if it's configured, I'm sure it will. Maybe one reason of the error was because we didn't have the permission on the layer. Maybe logging in with I go back to the question. One possible thing to do is to use, for example, the QGIS topological editor using the WFST standard right now. I am not aware of tools that are being developed with such a feature on top of GeoNode right now.
So
But-
please submit it as
Yeah.
enhancement suggestions on the repository.
1 second.
So in CartoDB and ArcGIS Online, you could also visualize by doing categories and quantitative analysis. Can you do that on this? Like if it's shapefiles and showing polygons by density or other attributes, is it currently possible?
That's something in the works for the 2.5, as Paolo mentioned, automatic classifications by features.
Yes, we have this thing working in warm-up, and it's one of the things that we want to port to the GeoNode mainstream.
And currently, I was wondering if it's possible to create a kind of bookmark and export that view as a JPEG or a PDF.
You can create a map and save it with the extent, and then next time someone will open it, it will be open with that extent saved. If I understand correctly your question.
All right, I think we're done.
I think we're out of time.
All
Yeah.
We're out of time, but let's give appreciation.
Thank you.
So we're going to